data, and my phone just dinged because it's, oh no, that was a different person. All right, well, I believe, let me just double check. I should have something that automatically does this for me, but I don't.
That's all right.
So, Restream says I'm live. I don't know about LinkedIn. One notification. And yes, we're good. All right, welcome.
Hey.
It's 5 o'clock. It's
Great.
Thursday. And what month is this, David?
This is May, but in some parts of the country, it is referred to as Electrical Safety Month.
That's exactly right.
That's right.
It's international, isn't it? Isn't it a national safety month?
That's actually, you know what? That's actually a good point. I'm not sure if it's a international safety month. I don't know who would declare that.
Oh,
Is
it's
that coming out of The Hague?
ESFI. Hold on. ESFI Electrical Safety Month, right? Electrical Safety Month. We're going to put this one to bed. ESFI.
Yep.
LinkedIn.
Yep.
There it is.
Okay.
Okay, so we are on AFC. We are on ESFI's website. National Electrical Safety Month. It's a ESFI is a nonprofit organization dedicated exclusively to promoting electrical safety in homes and schools and workplaces. To commemorate National Electrical Safety Month each May, ESFI spearheads an annual campaign to educate key audiences about steps that can be taken in order to reduce the number of electrical incidents. And that's what we're doing today.
That's right.
Right. So, and that's what we do. That's what I do all the time on this session. We work to try to increase electrical safety. And today's topic is on AFCIs, the arc fault circuit interrupter, which unfortunately, in some cases, it gets everybody's blood boiling. I don't know why. You know what this is? This is.
Ooh, let's see.
This is my research. These are my papers and whatnot from all the different code panel meetings over the many code cycles. There's been underwriter laboratory reports, which we're going to talk about. I know we're going to get into that, especially when we get into the length discussions around the 50 and 75 feet. We have UL reports that we're going to be referencing. This one is titled Effectiveness of Circuit Breakers in Mitigating Parallel Arcing Faults in the Home Run Circuit. Hey, we got Ryan.
Very relevant.
We got Ryan Jackson in the house.
Hey, all right.
Yeah. So we're going to have, we're going to hit what I want to do. What I realized, David, is I've never done a session on section 210.12.
Really?
No, everything that I've done has talked about changes. I've talked about what a combination type is, what a parallel and series arcs are, and things like that. James Smith, we are live, and we're going to kickstart. No, wait, what's the saying? He says kickstart. We're going to kickstart this. No, jumpstart this. I don't know. He'll say it, but anyway, we've never really done. I've never really done a 210.12. So that's what I want to do, and I want to cover 210.12. I want to be able to walk away from this session and make sure that we all understand section 210.12 of the National Electrical Code. Pop that clutch. Dadgummit. Look, I got my power tie on for the call today.
Well done.
Yes.
I think I had a red tie on last time. I'm not sure.
No, you had a red, white, and blue one on. You were, yeah.
Wow.
Yep.
But Tom has a spreadsheet of all of my clothing for every time we get on this thing. This is good
yeah.
stuff.
I keep track.
I appreciate it.
I keep track. And you know what? Look at the book. Look at this. You guys are going to like this. Look at this book I found.
Huh. How about that?
The Art of Hanging. I'll tell you what. That's not a good book.
Were you an executioner at some point?
I don't know who wrote it, but oh my goodness. I found it on my bookcase. I don't know how I got it. Okay, here we go. Nihad El Sharif, Gustavo Chavez is in the house. Tamaki, I got your question, Tamaki. We are going to answer your question. I emailed it to myself over here, so and we're going to pop the clutch. All right, so let me get my, let me do this. I think this is the one I want to do it on. Eaton AFCI overview. This is a PowerPoint. No, oops, sorry about that.
There we go. All right.
There you go. And every now and then that little thing comes up. I got to figure out a better way to stream video and audio. Okay, so AFCIs. I want to talk a little bit, David, about why AFCIs. Then
Get
we're
that
going to
cursor out of here first.
I'm sorry?
Get that cursor out of here first. That's all I'm asking.
It is.
I think so. I think you got something right here. Maybe? No? Anyway.
I think that's
Never mind.
I think that's a little dinner on your tie.
It might be a little dinner on my tie. I apologize. I didn't mean to interrupt you. I apologize.
It's okay. So I want to hit the why AFCIs, which is basically built around the fire statistics, right? And the problems that we've seen in the home. We're going to talk a little bit about that history, get into the technology, talk about the code requirements. We're going to go through each of those paragraphs in 210.12, help you understand why it says what it says. And then we'll talk about troubleshooting and living with the AFCI at the end. My reference is going to be the 2020 code book, although the AFCI has a very rich past. You got your code book. That's a good thing. And you got your analysis of changes. So I know everybody out there is going to open up their code book to 210.12. And there were some changes in the 2020 cycle, but the workhorse of 210.12 hasn't changed much over the years. So I made this, I put this together a while ago, and I think, I'm not sure, I think it was with you on one of my previous calls around ground fault circuit interrupters. I think you and I talked Tuesday, right?
That's right.
Remember when I said I learned that you had no ground required in receptacles, and then you had a ground only it was laundry rooms, then it was expanded to basements and garages and outdoors, and then it was expanded into the rest of the home, and this was shortly after, I'm looking at the columns here, 1950s, 60s, so I'd have to go back to those code books to see when we started to require from a year perspective. But my message on here is that technology has changed from knob and tube wiring to NM wiring that we experience today, from a two-prong receptacle all the ways up to a GFCI and now an AFCI receptacle. And circuit protection went from those round fuses, and in some cases the fuses didn't even have an enclosure around them, right?
Right.
Up to a breaker that can actually communicate. Okay, I talked about this with, who was that with? Anyway, we talked about the whole fact that we have circuit breakers now that communicate, and you can get data remotely from them, and AFCIs have a microprocessor in them, and they detect bad arcs. So
that might have been Jennifer Plaskina.
That's who it was, Jennifer. That was right. It was Jennifer. So, making me thirsty now.
I'm sorry. I have a very dated West Virginia University Stadium Cup with all of the helmets.
Oh my goodness.
How about
that? That's very impressive.
I'll tell you what. I will say, Stadium Cups, make sure you take them home. I know they're like $10 at the stadium, but you can just use them over and over forever. So I have a whole stack of them, and the better half just loves having just random Stadium Cups all over the house. So you don't have to worry about that.
Perfect. That's great. You ain't right.
Yeah.
So circuit protection has changed considerably, and we already said that. Thermal overload. Now, the big thing with a thermomagnetic circuit breaker is the fact that I'm just going to do this. Hopefully I don't have you in my way. The key thing with a molded case circuit breaker is it's designed to protect thermal and short circuit, right? And I have a video on my YouTube channel that, hey, we got Felix Sandoval in the house. I have a video that shows how this works, and basically, this is a bimetal. And what I have to do is generate enough heat to bend that bimetal and let the latch drop. That's for a thermal. A short circuit is, I call it the clapper, for the lack of a better name. I mean, it's, here, let me make this larger. Do this. Hello, there it is.
Yay!
I was gonna say, so on this internal view of that circuit breaker is delete. There we go.
Yeah. So just I was just going to mention, so like
Go
the
ahead.
bimetal, this is my understanding how it works, and you feel free to correct me as soon as possible. So with the bimetal, the whole point is that between those two metals, the one heats faster than the other.
Yep.
And so as the current continues to go through, that's essentially where that particular handle tag comes from, where once it hits 15 amps or 20 amps, then that first metal overheats a little bit faster and expands more than the other one, to the point where it actually physically bends, so it trips the breaker. And so it's a physical, like, there's not any type of calculations being made, or there's not like a processor on the inside or anything like that.
Correct.
It is a physical bending of the two metals to the point where it is physically coming apart.
Right. And well, what happens is that this it doesn't come apart. What happens is, well, it to your point, it drops. So this is your bimetal right here. Okay.
Right.
And then what will happen is it will bend, and then my latch will fall.
Right. Okay. Yeah.
Okay.
Yeah.
So and what happens is this here is your arm. This is your latch. This is a breaker that's in the open position, so it's got to
Sure.
move up. But in any case, that's basically, you said it exactly right. It basically, that metal will bend, the latch will fall, and it will open. And to determine from an ampacity perspective, from a protection like 20 amps, the amount of material that we have, our scientists will sit down and tell you what the composition of the metals are to get you to bend when we need it to bend based upon that current. So, but it's a very mechanical, to your point, a very mechanical device. So the trip curves for this are very wide. Now, on a magnetic perspective, the your magnetic armature is this guy right here.
This is my favorite part.
This is your magnetic part, and then what happens is, when you get enough current flowing through it, the magnetics will suck it in, just like the clapper, and cause the that's why I call it the clapper. I mean, come on.
I understand.
Yeah. So it sucks it in, and then the latch drops. Now, this is a very mechanical device, and what do I need to get the metal to bend? What is that? It's heat, right?
Of course.
What generates heat?
But
The current.
Sure. Yes.
Yes.
Okay.
I'm walking you down this path.
Is this as basic as it's supposed to be? Is this a trick question?
It's not a trick question. It's a.
This is like the guy that you had like that buzzer in your hand whenever like it sticks it out of your hand.
No,
No. I'm
no.
not shaking that guy's hand anymore.
This reminds me of my cousin Vinny, and he goes, what are all these things? You just spout them out. They're bushes, right? Okay. just shoot it on out. Don't hold back. So the this device is it needs a lot of current, and it needs to be persistent for me to generate heat. If I was on my stove, say I had an electric stove, and I turned my burner on and off, on and off, on and off, I could put my hand on it. I'm not going to get burned because I'm going to turn it on and off. But if I turn it on and let it heat up, now I'm going to generate heat. So what happens during an arcing event is I'm not drawing enough current through that bimetal to heat it so it bends, and I'm not generating enough magnetic forces to drop that latch. And this is Lance and Raleigh did this one. So, and I have this cutaway, right? So there's my bimetal. The heat heats up, and then I'm supposed to click this, and then boom, it trips. So the current flows through there and it trips, and then the magnetic, we just talked about that. And this is even a nicer shot of the clapper right there. You know, that's a clapper right there, man. That's like
Right there it is.
all it is, man. All it is. So molded case circuit breakers are listed, and I said the AFCI circuit breaker is the 2 Utes. That's what we are. This molded case circuit breaker, the AFCI is the most tested circuit breaker on the block. You got 489, which is the standard thermomagnetic circuit breaker. You have 1699, which is for AFCIs. That's the arc detection. You have, if you have GFCI, you have UL 943, right? If you have GFPE, it's 1053.
Right.
You have UL 1999, I think it was, which looks at the brains inside to make sure that you don't have any problems with, I think they call it UL 1999 because of the, the Y2K issues that we were worried about, I don't know. That was probably before you were born.
I was not before I was born. Jeez.
Oh, I love it. So,
all right, so we got some GFCI stuff here.
Yes. So GFCIs. What my point here, and Tamaki had the question. I got to call up the email from Tamaki. 1 second here, because the question was around. Tamaki Ono says compatibility between GFCIs and AFCI, the requirements in the codes. So first thing I want to talk about is the fact that a GFCI and an AFCI do 2 different things. Okay? So the first hurdle you've got to get past is the fact that I've had people say you can't put a GFCI receptacle downstream of an AFCI circuit breaker. Or I can't put an AFCI receptacle downstream of a GFCI circuit breaker. So they go back and forth with those technologies, but in reality, they don't compete with each other.
Right.
GFCI, we covered that on Tuesday. That is shock protection. Any current that goes outside of the path, the GFCI will trip. AFCIs aren't looking for that. They do look at current that goes outside of the path, but they're looking for arcing signatures.
That's right.
So you can put an AFCI and a GFCI in the same circuit. So there's no compatibility issues. And when we get into the language, the challenge when these questions that Tamaki was asking about the compatibility of the NEC requirements is when you have an AFCI and a GFCI requirement for, say, a kitchen. And what we did in 210.8, and I think it was 210.8, we said that GFCIs have to be readily accessible. So the question would be, where's the receptacle on a refrigerator? Typically, where's your refrigerator receptacle?
Behind the refrigerator.
Right. Is that readily accessible?
I would not deem so.
It is not. So then the challenge would be, right, to say, well, I would have put a GFCI circuit breaker in there. What about if I had a GFCI receptacle feeding that, where would I put my AFCI? So we're going to talk about those different configurations as we get into the National Electrical Code. But the first step in all of this is to understand there's no compatibility issues between a GFCI and an AFCI. They can be on the same circuit. There's no compatibility concerns. There's no one's doing the other's job. They both focus on something different. And I'm just trying to figure out. Okay, so that's that. And then we already said GFCIs are listed to 943. A GFPE is 1053, which is not personnel protection. that is equipment protection. And the level of current that it picks up is determined by the manufacturer or the design engineer. But if I have an AFCI, GFCI circuit breaker, they're listed to $16.99. It's listed to $489. It's listed to $943. And there's a couple other standards that it's listed to as well. Very well tested overcurrent protected device. But these devices are I can put everything in one device these days. David, can I buy an AFCI, GFCI receptacle? A receptacle that has AFCI. This is an easy question. Just spit it out.
I'm going to say yes.
Oh, very good. Yes, you can. Yes, you can. So you can buy an AFCI, GFCI receptacle. I can buy an AFCI, GFCI circuit breaker.
Right.
So I can put both technologies in the exact same device. I
Right.
can buy them separately. I can have an AFCI breaker or a GFCI breaker. I can have an AFCI receptacle or a GFCI receptacle. Go ahead.
So I have some heartburn about this.
What do you have? What's your heartburn?
So if you have an AFVF or a dual purpose receptacle, and this might be putting the cart miles in front of the horse, and we might be talking about this a little bit later.
Go ahead.
So we're eventually going to be talking about protecting the home run, right? We're going to be going into the depths of 210.12 and all
Yep.
the different ways you can go about protecting the home run and all the different ways you can go about that and all that kind of stuff, right? How does a dual function receptacle remain compliant with 210.12 by protecting the home run?
It's permitted, and I'll show you. We'll take a look at the language, but you have to follow the rules
Right.
in 210.12 with the length of the conductors, and we'll explain why with the length of the conductors are there and how we came up with those numbers. But that's a good
Can't wait.
question. Yes, we're going to hit that. And so Robert says the dual function breakers versus combination AFCI breakers, people confuse them. And we're going to
I was
talk
thinking
about
about this today. Yeah.
we're
So
gonna,
I think, can I go ahead and just like kind of riff on this one
yeah,
personally?
yes,
So combination AFCI came about before dual function breakers, right? Like that, it makes sense. I think combination was too good of a phrase
yeah,
for the time, because combination just is simply just combining its parallel and series arcs,
ooh,
and everyone just assumes
I'm gonna, boy,
you're gonna kill me.
you fell right into my trap.
Here we go.
Oh man, where's my soapbox? Where is my soapbox? Because what you just said, I hear it all the time. I used to
All the
say
time?
it, and it is 100% wrong. I
Wait a
love
minute,
it.
wait. Can I rephrase? Is it the high and the low that
Huh?
I'm mixing up? Is it the high and the low arcs that it's
Nope.
actually combining? Man, now here we go.
There we go. You fell into this, and I hear everybody who teaches this topic will say a combination type AFCI is a combination of parallel and series arc detection. And that, my friend, is wrong.
Okay, I can't wait to find out. We're all going to be learning something here.
Yes,
Because
I
thought that
love
was
it.
the case.
I
But
have
okay, to go back to the point very quickly.
yes. So the point,
Dual function breakers and combination AFCI breakers are definitely not the same thing.
a
And
dual
I don't
function.
think dual function
Yes,
is a good enough title from the industry to fully encapsulate everything that particular breaker or receptacle does.
that's right. So and the unfortunately, and I never liked the term combination type AFCI for this reason. Combination, I just don't like that term, but it's listed, it's in the standard for the type of circuit breaker and this type of circuit breaker and what it does.
Right.
But we came up with the new term when we started coming up with 943 type of devices where we put that technology in. We couldn't call it a combination because here's what happens, David. You get it on a job site and they think, well, I've put this in. It's giving my GFCI protection and my AFCI protection because it says on it combination type AFCI. And if you make that mistake, you think you're providing GFCI protection, but you're not. And we'll help you understand exactly what that means. But so it's really important, to Robert's point, that we got to understand when we start talking a device like this, say a breaker that has GFCI protection, it's dual function. It's two functions. It's AFCI and GFCI.
So I would. This is we're getting very lawyerish here, and
Sure.
I'm going to make an argument. I
Please.
think that dual function, it should combine all of the things that the combination one's doing, because the combination one is doing more than one thing, right? And so you can list all of the different types of arcs that you're protecting from and GFCI, to where dual only sounds like it's two.
You're right. Yeah.
So I don't know how you do that.
Yeah.
Right. This is the guy that's pointing out something and it doesn't have a solution.
Well, but
the,
you know,
the great
I think
guy that I am.
your point is, and I think what my point is, that if you don't understand what you're talking about, you can make a mistake thinking you're providing a certain level of protection.
Yeah, absolutely.
That's I mean, but bottom line, you want to know that when you put a breaker in, if you want it to do combination type AFCI protection and GFCI protection, or combination type AFCI protection and GFPE, then you've got to read that label and read the instructions to make sure that you understand the terminology, because don't just think combination type, that's what it is. And I hear people do that all the time.
So we're getting into the weeds here, and I apologize about that. But
this is good, because we're gonna dispel this myth. This is one of the areas I try to. I mean, it's a personal issue, and I'll even say it now. I'll say, yeah, it's combination type is parallel and series, and knowing that the person I'm talking to is probably, that's all they need to know. But if you hold me down to the fire,
that might have happened to me.
Well, I need you to I need you to start propagating the right stuff out there. So the big thing with an AFCI is, I'm just reading Tamaki's, in general, when it comes to protecting from both shock hazard and fire hazard in place like a kitchen, what is the typical circuit configuration? We're going to talk about that once we get a little bit further into this. Okay. Are there any listed products combining AFCI breaker and GFCI receptacle outlet? So we just hit that question. So Tamaki, you can get an AFGF breaker. You can get an AFGF receptacle. So we got both technologies in both ends of the spectrum.
So wait, his question there was an AFCI breaker and a GFCI receptacle?
Well, I think what the basically it's are there any listed products combination of AFCI breaker and GFCI receptacle outlet, or GFCI breaker and AFCI receptacle outlet? So, and what I'm interpreting that to mean, are there anything that combines both technologies? And yes, the answer is
right.
You can get it in both a receptacle and a breaker, get both technologies inside each one of those.
I guess I would say no, but, and then say that, right?
Yes.
Because I don't know of any particular system that has an AFCI circuit breaker and then and them being listed together as one system.
We make one.
Oh yeah, I know. AFCI. No, but we don't have a GFCI receptacle, AFCI breaker, and it's listed together as a system.
Right.
That's all.
That's right.
That's all.
It's absolutely right, and they're not put together. Right.
They're not listed together. It's not like
That's right.
In that particular sense.
That's it. You're absolutely right.
We're being very pedantic today. I learned that word.
Whoa!
Recently.
I just learned a new word. What's pedantic?
There you go. Exactly what we're doing.
Okay.
It's being, what is it, like, detailed to the point of being like losing.
Absurd.
Yeah, essentially.
Okay. So, arcing faults, right? And I thought I might. Oh, here, this is the picture I was looking for. So you have, and here's what I will here's. I think I'm going to just talk a little bit about the combination type AFCI, and I think to understand why the combination type AFCI came on the market, You have to understand the difference between what we had before, which is the branch feeder AFCI, and the combination type. And if you look at UL 1699, this yellow is your NM wire, right? That's your typical house wire that's installed in residential dwelling units, where you have a hot conductor, a neutral conductor is separated by a bare copper conductor, and there's usually a little piece of paper in there, right?
Right.
So 1699 test for a branch feeder, David, a branch feeder, this is before the combination type, tested this conductor for a fault for arcing line to line. Okay, we would cut, one of the tests, we cut this copper conductor out of the picture, and we create a fault line to line that doesn't include the equipment grounding conductor. Okay. So that way, you know, it's not going to ground. And we did it. We do a test in there, which I think I'm hoping that I have the test. We also do a test from line to, say, a metal pipe. We take a piece of like pipe. It could be conduit, could be, you know, just steel pipe. And we make sure that we can detect that arc. And I believe we do it on the neutral side too. We have an arc there as well. But in 1699 for the branch feeder before the combination type device, we also tested for a low 5 amp arc in series with that conductor. So a branch feeder AFCI device can detect line to line arcing, line to neutral, like, you know, your line to neutral arcing, your line to ground arcing, your line to a pipe arcing, and also in series at 5 amps. Everything else is done at 75 amp trigger point. So when I go parallel, I can I take my 3 conductors, I take this equipment grounding conductor out, and I cause an arc right across here. That trigger point, because it's a parallel arc, parallel with the load, is done at 75 amps because you're shortening the system. And we tested, UL did research, and they measured the available fault currents at all these different receptacles, and they found the lowest available short circuit current that they could find is 75 amps. So we make sure that we can detect that, which would be a parallel arc. But a branch feeder will detect a series arc in NM wire. And how we do it, we take this wire and we cut it with a blade. Okay. We cut it, then we wrap cotton around just this conductor. And we also, we wrap cotton around this conductor, okay? And we cover it. And then we draw 5 amps. And if that 5 amps trips, well, I have to detect, not if, it has to trip, right? And do you know how the branch feeder would detect that arc?
How?
What's in the middle of this, between those hot conductor and the neutral? A bare copper conductor.
Gotcha.
And so what would happen when I do this series arc, I would basically burn away the paper that's in between here. And I would create enough carbon that it would go right back over the equipment grounding conductor. And that equipment grounding conductor, the current going outside the path, I would put in all branch feeder AFCIs had ground fault protection of equipment at around 30 milliamps. I think Square D or GE was up around 50 milliamps. We were at 30 because we listed ours to UL 1053. We said, look, we're going to just list it. I mean, if we're going to do it, we're going to list it as a 1053 device. Nobody else did it. Okay. So they all had different trigger points, but that's how we passed this test. And it will detect a series arc in NM wire. So if we said the difference between a branch feeder and a combination type AFCI was the difference between a branch feeder did parallel arcs and a combination type did series arcs, that would be wrong, because this test for a branch feeder AFCI is a series arc test. What do you think?
It's a lot.
It's a lot to take in. And you know what? When we were arguing about the requirement around combination type AFCI, we made presentations to Code Panel 2 saying, why? I can detect a 5 amp series arc. Yes, I use GFPE, but you know what you would not detect? When I've got SPT2 cord, that SPT2 cord does not have an equipment grounding conductor inside. And the test in UL 1699 takes an SPT2 cord, we cut it, we split it back, and there was a debate. And technically, I think he was right. Dr. Engel made the arguments that says that's not a series arc to test, it is a parallel arc to test. And technically, he was right. But that type of an arc, and this one down here, you see what I'm breaking?
Right. Yeah.
I don't have an equipment grounding conductor. So up in my NM wire, I could detect this series arc at 5 amps, no doubt. But I could not detect a 5 amp arc when I don't have an equipment grounding conductor, because the method I used was GFPE.
Friend of the show, Mike King, asking if there's any significance to the 5 amps.
All right. So if you 5 amp series arc, I could not find why that 5 amp. I think that they looked at the types of appliances that would be driving, and Kevin Breen brings up the nuisance tripping thing. So think of these as thresholds. If my trigger point is 5 amps, if I took it down and said 1 amp, we could have a debate on whether or not you can start an arc or start a fire at 1 amp, which I have seen done. So I could never say that a fire could not start based on 1 amp. You could, okay? But the standard doesn't have to take into consideration all of that. They've got to be realistic and practical with regard to the compatibility stuff that Kevin's pointing out.
Yeah, I guess it's a cost benefit situation, right?
Yeah, if I'm detecting those low level, and then you have to think, okay, here's the other issue you come into. For example, I wanted to make a UL change for the OBC AFCI, that the OBC AFCI, and we're going to talk about this, looks upstream for arcs, right? A series arc upstream. When it trips, it still has an indicating light. And where's it getting power from? The line terminals, which is a damaged conductor. So I was having the discussion, and I said, why doesn't the standard say when it trips, you have zero current flowing? And it seemed like a logical thing to say, just put a meter on there and measure zero current. And if you get 0 amps, then you're golden. And they said you can't use 0 amps as the definitive point to say that something is not energized. And I was like, well, that doesn't make sense. And they said, Tom, put an ammeter on a circuit, and the needle's going to bounce. The numbers are going to bounce. You can never get true zero current. You're always going to get something, even if it's induced. It could be milliamps. You'll never get that meter to read zero. So you've got to come up with a different method. But in any case, that 5 amps also helps us adjust for those types of inconsistencies in metering and measuring and all that good stuff. So the AFCI combination, or the branch feeder, will protect all of these conductors. Your NM wire, that's what we were targeting. and it'll protect these connected cords for parallel arcing faults. What the combination type did was it introduced the ability to detect a 5 amp series arc in SPT2 cord. That's the only test that is in addition to a branch feeder. You have to cut one of those conductors in an SPT2 cord. You have to wrap it with tape, condition it with a high voltage to get some carbon buildup, and then you run a test at 5 amps, not at 75. So when someone says, what's the difference between a combination type AFCI and a branch feeder type AFCI? A combination type AFCI gets you 5 amp series arc testing on SPT2 cord. That's what it does.
As well.
Yeah, in addition to
Okay.
everything else
Yeah.
that the regular that it does, it gets you that one additional test on SPT2 cord, which is a series 5 amp arc. Now, here's the other thing to be mindful of when you get into troubleshooting. Knowing the trigger points. The series arc trigger is 5 amps. Let's say that I have my computer plugged into a circuit. I'm not drawing more than 5 amps on this computer. I mean, I work a computer, okay?
Oh yeah.
Oh yeah,
I've-
I work a computer, but I'm not pulling 5 amps.
He's
Now,
running the Mars rover on this thing, ladies and gentlemen. It's nuts.
That's right. That's right. Now, let's say that I plug in my, let's say that my computer, the cord has a problem, right? But I'm not detecting that because I'm not hitting that 5 amp threshold. Now let's say I plug in my vacuum sweeper, okay? And I turn my vacuum sweeper on. And now it trips. What am I going to blame? The vacuum sweeper,
Sure.
right? Because that's what I turned on when I was working, and that's what tripped the breaker. But the problem is not in the vacuum sweeper. The vacuum sweeper added enough load to the circuit to get you beyond that 5 amp threshold.
It's the straw that broke the camel's back, I guess, right?
Right. It was what let the AFCI detect the problem in that smaller cord with the smaller load. Okay, so you have all of these things going back and forth. And if you understand a little bit more about the technology, troubleshooting will become a little easier, because now you can look at it through the mind of the AFCI and say, okay, I know series arc is probably what I'm going on, because the 75 amp, the branch feeder AFCI, tried and true, hardcore, it works. Detecting a 5 amp series arc is a challenge for the microprocessor. It's a challenge for the products that you put on that circuit and all the noise. You take a look at dimmer switches, caused us a problem in the day. Treadmills with the variable frequency drives, all those nasty waveforms, right? A vacuum sweepers, they have these really nasty looking waveforms. So understanding these details helps you troubleshoot the circuit. The target is arbitrary, and bless the manufacturer for nailing it. Things are getting interesting from firmware point of view, not just magnetism and bimetal anymore. That's exactly right. You've got a brain in there that's looking at a signature. Do signals or frequency sent over the conductors affect the AFCI? Robert, here's the thing. I would say, it's the signals and frequency. So I remember way back in the day when we were experimenting with combination type AFCIs, when we were looking at that 5 amp series arc. We look at multiple frequencies, and most manufacturers will do this to detect that arc. They don't look at just the 60 hertz. We're looking at 60 hertz. We're looking at 120, whatever the numbers are, I don't even know. And some of it might even be patented on the algorithms that how we determine what is a good arc and what is a bad arc. So interjecting different frequencies, you would have to interject things in such a way that it hit the spectrum, right? Right. So you'd have to hit that spectrum to say, okay, I see it over here. I see it over here. I see it over here. We have algorithms that says this is a problem, take it offline. And you get to that level of performance in the device based upon your experience. The very first device we put out there, the very first one, looked at 1200 kilohertz or 1250. I can't remember. Whatever the number, I think it was 1050. Whatever the number is for KDKA in Pittsburgh, okay? KDKA would broadcast and we would pick it up, okay? So that made a difference, but we are so far beyond that. That was probably well before, that's when you were probably in consulting, or you might have been in college at that point, when
Maybe.
when we were going through all of those iterations.
And I actually do want to like mention something on that point, to where I'm pretty sure all the manufacturers do this, where there's something whenever it comes to computer logic, it actually just logic in general, it's called whitelist and blacklist security. And so it's kind of like being at like a nightclub, right? So the whitelist is the only people that are allowed in are the people that are actually on the list. This list is the good list, and
Yeah.
only names on this list are allowed in, right? The blacklist is that everyone else is allowed in except for these people.
Yep.
Right. So the way I kind of look at AFCI is that the way we kind of avoid having signals and frequencies and noise kind of messing it up is that there are very specific signatures that we know are bad.
Yeah.
We will let, for the most part, everything else go other than the things that we know are dangerous.
Yeah.
Or we'll trip on them.
Or it could be the opposite. We could say, look, that, whenever Ryan Jackson gets plugged in, okay,
right.
Ryan is a noisy guy. And we know what Ryan looks like, right? We know what his little signature is when he's flapping them gums. So we will tune that out.
Sure, we do both. You're exactly right.
Yeah, so we could say, I know it looks bad, but I know it's good. And now I'm going to put that into the good bucket, and I'm not going to trip on that when I see that specific characteristic. Now,
That's
Ryan asked don't let Ryan in. That's right. Now, Ryan asked a good question. He says, are we seeing new consumer products with non-sinusoidal waveforms that older AFCIs view as dangerous? And then can AFCI firmware be updated? So here's the challenge with that. Can I update the firmware? Sure, I can update the firmware, right? I could, in fact, we have a circuit breaker, right, David, that I can put online. I can have it wireless. I can give you your energy information. I can tell you what the current that it's pulling. I can give you all this great information. UL does not permit me to change the protection schemes when I'm downloading new firmware. That is like a UL, you got to put yourself into the mind of, we're used to it with the phones, right?
I think this is a cybersecurity issue. Is that right?
Well, it's more than that. It's more. Okay. What if there's a bug, right? What if there's what if? Okay, let's say your cell phone. In fact, I just got an email that said there's a new version of I got
Apple OS.
Yeah, so when I go to general and I go to software update, right, it'll come up and it'll say, hey, you got a new version. Yeah, iOS 14.5.1. Now, what I will do is I'll plug it in, I hit download and install, and I wait, right? What if this phone was on your life support system? And you sat down and said, oh, I got a new update to my life support system. I'm going to hit download and install, right? Okay. And now it depends on whose life support system it is, obviously, that, on who's pressing the button, right? But in any case, if I rely on this for a safety function, downloading new firmware, who's to say that, hey, you unplugged it, and then you plugged it back in again, did that hurt the interruption? Will that cause the device to go brain dead on you? And now it's not providing the protection. So to answer Ryan's point, is it technically possible? Absolutely. Are we thinking about it? Yes, everybody is. But the standards need to change to be able to permit me to download firmware. So right now, if there is a known compatibility issue, typically what we would do in the past is we would give you workarounds to say, here's what you can do, and this will work fine. I know for treadmills, we had a little wave trap that would just go in the cord. Sometimes ferrites will filter the stuff out that we don't like or whatever. But and it'll depend on the manufacturer. But downloading firmware is a challenge because of all of the standards that would need to be developed to make sure that when you download it, how do you verify you did it correctly? Will it provide the protection afterwards? All that jazz. But that is a really good question. Electronics in furnaces and microwaves affecting operation not passed in Nebraska for this equipment. So 210.8 GFCI. So furnaces and microwaves. I don't know about problems with furnaces and microwaves. The only place I have seen any debate and discussion, and it's all a matter of public record, is around HVAC, that outside condensing unit, for GFCI issues. I've not heard of AFCI issues. Remember, AFCI is only required on 15 amp and 20 amp circuits. That's it. If your microwave is tripping the AFCI, there's probably a problem in the microwave. Or there's a problem somewhere else and the microwave is putting it above that 75 amp or 5 amp threshold. Right?
Right.
Air conditioner condensing units. Yep, that's right, Robert. All right, so we talked about the waveforms, talked about the different types, the pigtails. I'll never forget when we introduced the plug-on neutral. You ever watched WKRP in Cincinnati?
Yes, actually I have.
Okay.
Yes.
All right. So do you remember the episode when they threw the turkeys out the helicopters?
I can't say that I remember that.
Well, they learned that turkeys didn't fly. What I wanted to do was cut the tails off of pigs.
There you go.
They wouldn't let me do it, though. They said that would be cruel to the pig. And I said, no, we'd anesthetize and we'd get a doctor in. It would be very humane. We just wouldn't have tails. But
can I share something very quickly about WKRP in Cincinnati?
Yes.
Favorite joke, or at least whatever. One episode was where a particular character was dating somebody that was a lady in the night, and someone was trying to break the news to that particular person, and they were trying to say that she has the oldest
profession.
Occupation.
Yeah.
Yes.
Yep.
And he's like, she's a farmer.
She's a farmer. Yep. WKRP.
7-minute warning, by the way. We still limiting this to an hour because we have.
No, we're gonna go on. I know we're gonna keep going. So refrigerator. Right. Kevin Breen asked about the refrigerator. So, remember, AFCIs have been required in kitchens for quite some time. If there was issues out there, we would know about that. I have not heard of refrigerators. I've heard of appliances on the GFCI side of the business. Again, it's that leakage current. It's what are they doing with that leakage current? Are they putting that over the equipment grounding conductor? But I can tell you, I have not seen major compatibility issues with refrigerator circuits.
Yeah. By the way, Kevin, if you're having trouble, like trouble with product that is recent right now, get a hold of us, because I understand this has been a past issue. But whenever it comes to this particular technology for AFCI breakers becoming more and more mature, with the latest and greatest and all that kind of stuff, we're seeing less and less of that to the point where people that used to be very anti-AFCI in code state adoption meetings that I attend, or at least attended whenever Tom was there, just 2 or 3 years ago, whenever he was a younger man, that these people are now proponents of AFCI because the technology has come so far throughout all the manufacturers. And if you do still have issues, you can go and look at AFCI safety.org, which is what Tom has up here. And was it unwanted tripping report?
Yeah,
right.
And
Please
that
let
was
us know about it.
And that was under homeowners.
That's
unwanted right. Tripping report. You put your name in, you fill this information out, and more specifically, you say, whose product you're having issues with, because don't call David about a GE or Siemens or other devices, right? And this here will be the tool that you can use to provide and get somebody to call you back.
Sure. Hey, if you want to call me about anything that's not Eaton, great. We'll just figure out a way to sell you some Eaton stuff.
You know what? That's true. Just call David Smith. Absolutely right. Yeah, I never thought about that, because we have classified breakers that can go into existing, and those are UL listed as classified breakers that can go into an existing competitive panel board, because our technology might be a little better than the other guy's technology. Just saying.
Might be.
Is.
To the point where we brought up a product to be able to do that, because we're sick of taking other people's calls. Anyway.
So we talked about we talked about a little bit of everything. Sorry, hold on. Spam risk.
Papa John's
spam risk.
That WKRP, was it, you were the caller number 10?
I'm caller number 10. So NHZX boy says, personally, I've had zero trouble with any industrial electrical designer here. Thinker here too. I run my mouth in respect to theory, not bad experience. Awesome.
Good
All
stuff.
right. So temperature. So this is a picture that was detected by an AFCI in my brother's house. Actually, there was no the insulate. It was an older home, retrofitted into an older home. So another thing to remember, I don't need an equipment grounding conductor for this to work. Right. So I can have knob and tube wiring, and I can provide protection. I can have the older wiring like this is, that does not have a equipment grounding conductor associated with it. It has just a hot and a neutral. All right. So I can provide that same protection. And, these are just pictures of problems that we found. And rodents, this is a rat or whatever gnawed, and it's to blame for an electrical fire. So we'll detect all that good stuff. And these are just, again, we've had recalls on products that we've identified that had problems. And look, even a dog bed.
Don't say we had recalls.
No, not us. No,
Jay Haugen will be very upset if you say that.
Yeah, no, not us. No, we've identified products that have been recalled, and things like that. But these are all products, appliances that have been recalled because of some sort of hazard, and they eventually, you're going to probably find out that that's a bad product via a GFCI or an AFCI product looking at it.
There might be some of that going on the other side of the AFCI, GFCI stuff. Just saying.
Yeah.
We might see some of that going on here pretty soon.
Absolutely.
Spoiler alert. Not going to talk about that.
Not going to talk about that. So you've got, and I always talk about this. You got the phases of construction. Let's get to. This is looking at the average. The case study. I already told everybody about this. Hopefully, you guys they were able to watch the Chiodo videos. That is the wire that was in his home. I'm not going to go down this road because they've been able to watch that. Okay, so we talked about, these are some of the standards: 489, 1699, 1998, not 1999, and 943 and 1053. Programmable, right? So we talked about that. I want to get to the code requirements. Let's get to the language here. Oh, okay, yeah. So, all right. So first off, let's just answer Tamaki's question about how do I handle a kitchen? Because we've got it right here. We added kitchens into this picture, and we added kitchens because appliance manufacturers came to panel 2 and said, hey, we have the end of life of some of these appliances have been known to start fires. They brought data to the table. And I commend the manufacturer who did that, because they put a lot of information out there that says, look, this stuff will fail. Now, how do you handle a refrigerator that's within 6 foot of the sink, right? The receptacle that's within 6 foot of the sink, and I have to AFCI and GFCI protect it, and it has all of that protection has to be readily accessible.
Right.
So one way to do that, I could put AFCI protection in my circuit breaker. I can take that branch circuit down to they call it a blank-faced receptacle. And we make these. Blank face GFCI. I call it a blank face. I don't know if that's right. Oh, look at that. Eaton blank face GFCI. And what that is it doesn't have because the concern with a refrigerator is you don't want to be plugging everything in and trip the circuit breaker thermally because you've got a crock pot that overloaded the circuit and now you lose your refrigerator, right? I'm not going to take the survey. So what you could do is put this, it's called a blank face. There's no place to put anything into it. And you put this in a readily accessible location. This device is giving you your GFCI protection. The breaker is giving you your AFCI protection. And now you've met the code and it's all readily accessible. Or you get a circuit breaker that has AFCI and GFCI in it. And now you don't put a standard receptacle that you're going to plug your refrigerator into and you're done. Go away, leave me alone, because you've provided AFCI and GFCI protection. Or you get one of these puppies that has AFCI and GFCI in, and that's providing the protection for the GFCI, and also it's giving you your AFCI protection, but you've got to make sure you meet the code requirements for the proper application of a wiring device, an OBC AFCI, which is an outlet branch circuit AFCI device.
Right. I just want to make sure I'm hearing you correctly on that first particular application you were talking about for the blank face GFCI. So you're saying AFCI circuit breaker and use a blank face GFCI receptacle.
No.
And so
you would have this device.
Yes.
And then this would feed the receptacle.
Got it. Okay.
Yep.
So that would be upstream from the receptacle that's actually going for the
refrigerator.
And that is going, and if you're going to go with that, that would be at a readily accessible location.
That's exactly right. Yes.
Yeah.
And I've seen people put these devices in like in their basement, and they say, okay, I'm going to put my GFCI protection. I'm going to put these little blank faced items here where it's easy. They can go find it, or they put their GFCI protection so that you're not hunting for the receptacle where the GFCI is, right? So,
sure.
I mean, because 99% of the time, you got a circuit that's dead, and then you got to go figure out where is the receptacle. So, and it's usually behind a piece of furniture. Anyway,
sounds like you're making an argument for GFCI or dual function circuit breakers, because it's always going to be in the same place.
We make them both.
Sure, I understand.
We make them both, and I know in my house that's the way I went, because I know if a circuit goes out and I'm traveling, when Bobby Joe calls me and says the circuit's out, I tell her, go down to the panel board, look for the little red flag on your breaker, close it. If it's GFCI, whatever. So
now, was that red flag factory installed?
Yes, it was. Yes. Perfect. So the first option is, so this is the parent text. This is where we have the laundry list of locations, right? And I think the 2023 cycle, we're arguing over adding some more rooms and all that jazz. We always argue over expansion. I mean, it's just the way it is.
I think from the 2017 to the 2020, just to make sure, and also for anybody that's listening from the great Commonwealth of Pennsylvania that is going to be updating to 2017 soon, largely the same from 14 to 17.
Yeah, so that's interesting. The great state of Pennsylvania is just adopting the 17 code.
Welcome aboard, buddy. Doing my job over here. Right?
You're doing your job. David,
yeah.
You and I need to, don't say that. You're doing your job.
I can only do so much of what this government does. So to the point where, I mean, actually we made some good updating for Virginia. just recently, to the point where they used to only be AFCI in bedrooms, and they were on the 2014 code. Now they're updating to the 2017 code, but they're advancing from only having AFCIs for bedrooms only for dorm or for dwelling units, to the point where it's going to be full AFCIs until you need GFCI, which makes it seem like they are competing technologies, which is not true. But also, Ryan Jackson, we were working on Indiana. We were working on it. So I believe if I get this correctly in my head, the Indiana Electrical Code updated to the 2017, and they're now going through updating the Indiana Residential Code, and they're thinking about doing the 2020. Or it might be vice versa on the IRC or IEC for that particular state. And Kevin, we're working on. Actually, I think New York City has not touched any code since COVID, from my understanding.
Well, wait a second. Hold on. COVID hasn't been around since 2014.
No. I mean, my understanding is, and he can let me know if this is the case, that they were going through the motions on doing code adoption for some addition, and then since COVID, they have completely not brought it up. And I think the same thing in Alaska, and I think the same thing in the great state of Louisiana.
Wow.
So, yeah.
So this is the first option in the laundry list. That's fine. That was good discussion. Good discussion. So this is your first option, where you have a listed combination type AFCI installed to provide the protection of the entire branch circuit. And from a panel 2 perspective, this is sort of the passion around the code panel. Is they want to make sure we protect the entire branch circuit and the connected cords. And what the combination type does is get us that 5 amp series arc for these connected cords, right?
Right.
Due to a lawsuit in Wisconsin, I believe when any jurisdiction adopts a standard, that standard must be available for. Yeah. Well, you know what? You can, and that, he's right with regard to the providing the
it's the cost effect, the cost impact.
No. What he's saying is you can't mandate the National Electrical Code and then require them to buy a copy. So you can go online for any ICC codes, NFPA codes, and view them for free online. So Ryan Jackson in the house. See that? You can view those for free online. No charging associated with it. Now, you can view them for free. You're not going to be able to print them, copy and paste them, and do all the great things. They just give you the bare minimum that you need to meet that language. Yes, sir.
Legally.
That's right. Yeah, that's exactly right. Legally. Yeah. You may be able to, but you might be able to take a print screen and all that other good stuff. But you're right. You would be violating the law, and that's not what we do on this channel.
Absolutely not.
Right.
No.
We're law and order,
here, buddy.
Law and order.
Here it is, paper version.
Beautiful. Okay, so this is your first option. Now, your second option is a listed branch feeder type AFCI. So this is the branch feeder installed at the origin of a branch circuit in combination with a listed outlet branch circuit type AFCI. Now, there's no distance. No, Ryan Jackson, standards are not viewable for free. But you know what UL does is they publish, it used to be the white book, and it's now product spec. So what they do is they give you the information you need out of the standard to properly apply the product. Because if you viewed the UL standard, I mean, I've looked at UL standards and I can't figure them out. So they repurpose that and they try to give you what you need in the white book, which is now UL product spec or whatever they call it.
Yeah, I think you can look that stuff up through the product type, right? Like I think I've done that a good bit for TRs. I can't remember but it's like normally 4 digits of whatever, but yeah,
4 digits of fun. So this one here, now the reason, David, that why is there no distance, no length of this OBC? Why isn't it 50 or 75 feet?
I don't know, Tom. Why is it?
Because the branch feeder AFCI provides the parallel arc and series arc protection for the NM wire. You're
Gotcha.
protecting that that home run circuit from arc fault protection. So the OBC doesn't have to, you have no vulnerability with regard to series arc or parallel arc of the home run circuit. All right. So no distance, but here's the challenge. Try to find a branch feeder AFCI.
That's actually what I was going to ask, because, okay, this might be getting too far down the road again, but I understand in this particular code book here, right, that there are particular sections in the beginning of the book that talk about the accessibility whenever it comes to market, right? The commercial availability of particular products.
Right.
I would, I don't know. I mean, I haven't looked in Lowe's or a Home Depot for a branch feeder AFCI, but I'm positive we have them available. But whenever it comes to field application, I wonder how many people are really picking number 2, A2.
No, and I don't know of anybody who's doing A2. No. Now, and you know, we could say, boy, a public input that says just remove it, but it would fail at panel 2 because we would say it is a solution. I can't just take it out because, hey, you know, they're hard to find. So it's a viable solution if you have this combination of solution products.
The way I kind of look at it is we, meaning the electrical industry, is providing as many options, solutions,
yes,
to however you'd like to do it. And so this is just another way of kind of understanding the means and thought analysis of the greatest code making panel outside of code making panel 9.
Yeah, well, and understand too, and this is where things are going to get deep. Okay, so the third option is a listed supplemental arc protection circuit breaker, and I'll tell you exactly how this came to be. I was in the room when they made the decision to put in 3 and 4, and it wasn't at the code panel meeting, it was a task group meeting that was in a separate room, and the task group, remember, code panels break out into task groups. You have, for panel 2, we've been doing it well before what we do today. So what happened here, remember, the battle is always between, historically, now that, you know, 2 manufacturers make both the wiring device and the circuit breaker, the battle
Are we about to talk politics? Is that
yeah, it's politics. I mean, if you want to say, why is it here? It's, this is hardcore why it's here. I'm not gonna, I mean, I agree with you. Hey, yeah, we want to bring as many options, but if you want to know why 3 is there and why 4 is there, this is it. Right, wrong, or indifferent, it's the fact of life. So the battle has always been between the guys who make the receptacles, this guy, and the guys who make this, right? And why? Because
commercial. It's commerce.
yeah, I want to sell one of these. I want to sell a receptacle, right? And the history behind this has been you protect the entire branch circuit and connected cords. GFCIs are different. GFCIs just look on the tail end, what's plugged in or what's downstream of the GFCI. So at the panel meeting, at the task group meeting, they were talking about providing a level of protection and permitting the use of an OBC AFCI. And at that time, the receptacle manufacturers were saying, we're not going to bring one to the market unless you put a code requirement in. And they would stand along each other's, they would almost hold hands and stand along the wall and say, we are unified. If you make a change in requiring this, we will bring a product to the market. And panel 2 is like, well, how do we do this? So UL did research. And there's the 2 things. Remember, the panel 2 is adamant that there is you provide protection for the home run circuit, period, right? They don't want to lose any protection. So UL did a study to say, how do we provide protection of this conductor? What do we call that? The home run circuit.
Sure.
Now, arcing faults. You could make an argument. You could say, look, parallel arcing faults and series arcing faults. If you have a problem, if you have 100,000 amps available fault current and your breaker could interrupt 100,000 amps, if you have an arc in that conductor, it's going to be more than 75 amps. It's going to be more than than 100 amps. It's going to be more than, it's going to trip the thermomagnetic circuit breaker. So what the wiring device manufacturers were coming to the table saying, hey, look, if you have an arc in that home run circuit, a parallel arc, because that's the only thing, because the OBC AFCI, which we didn't talk about yet, the OBC AFCI basically does everything that this breaker does, except it can't provide parallel arc protection of this home run circuit. And we could debate on whether or not you can provide series arc protection, because think about it. The way the OBC works is a series arc will, because current's flowing through the damaged series conductor, through the receptacle down to the load, that receptacle will see that waveform.
Right.
And the receptacle doesn't know if it was downstream or upstream, but it knows I see a bad arc and it can open. And if it's the first outlet, then it's isolating and stopping the flow of current through a damaged conductor. Okay? But we've already talked about it's getting power to light that light off of that same circuit. So that's technically not true. But we're going to ignore that. We're going to say, okay, it's just a small amount of current and it's not going to do whatever. So that device arguably can detect a series arc in the upstream, and I could have a good debate and argue whether or not you are actually protecting it, but I'm going to give you that. So that device is stopping the flow of current on a damaged piece of conductor. So technically they're saying I'm providing series arc, but you're not providing parallel arc. Now on the parallel arc, David, they're saying, Tom, if you had a very high available fault current, if you had a parallel arc, it's going to be greater than the instantaneous pickup of that circuit breaker.
Sure.
And that's going to trip the thermomagnetic circuit breaker. So what they wanted to do was say, look, put an OBC downstream of a thermomagnetic circuit breaker, and the thermomag breaker will take off the short circuit current if there's a parallel arc fault. And the OBC looks at series arcs and gives you complete protection downstream. Panel 2 said, when they first tried this, they said, no, we're not going to do this. We actually, for one code cycle, we said 6 foot. I think it was 6 foot. I'd have to see which one that what we permitted 6 foot or something like that. I can't remember where it was, but I'm going to have to do some homework there. I don't know if Ryan can go back and see where we had 6 foot, which code cycle. I believe it was 6 foot. But in any case, UL did studies. They did 2 studies. The first one they published wasn't quite right. They missed a couple important details. And the title of that study, that's why I got my papers out. The title of that was Effectiveness of Circuit Breakers in Mitigating Parallel Arcing Faults in the Home Run, because that's what they're debating. The panel 2 was saying, look, what can this circuit breaker actually detect from an arcing perspective in the home run circuit? What's the vulnerability there? So they published this report, and they came up with Dr. Bracis, very smart guy. He published this data. I mean, he's got waveforms in here and all this jazz. And what you have to do to determine what you can protect with this circuit breaker is you got to know what the fault current is, right? And B, you've got to know what is the instantaneous pickup of that circuit breaker. Okay, so I know the size of the conductor. If I know the size of the conductor, I know the impedance of the conductor. And you can watch my videos on how to calculate short circuit current, because that's all they're doing is just saying, okay, we're going to calculate a short circuit current here. We're going to determine what is the length of conductor, 2005, 6 foot. Thanks, Ryan. So the length of conductor is basically a recipe using an equation that Dr. Bracis came up with in this test, and plugging in the instantaneous pickup. So you want to know how much impedance can I add to get that fault current down to a number to where I am within the instantaneous region. Now, I haven't seen equations like, you can't see it. I haven't seen equations like this since college. I mean, we've got some really good work here from Dr. Braces. Now, the problem was there was a couple things that he missed in the first draft, because remember, this was one of those things, David. You've got a public input. You've got to get a report out really fast. Actually, it was trying to get a report out for the public input phase. He got it out. Panel 2, we looked at it and we said, hey, you got to tweak this. So they worked on it for the public comment phase. Now, the problem with the instantaneous was that UL 489 does not require an instantaneous on a molded case circuit breaker. The fact that it doesn't require it, and I put it in, means that UL is not looking at what is your pickup, right?
Right.
They don't care because they don't even require you to put it in there. Why do I put an instantaneous in a breaker? To protect the circuit breaker, okay? And what's the challenge with the instantaneous pickup is, do I trip on things like inrush currents for motors and stuff like that? So you can buy what we call high mag breakers, right? We sell those in environments where we know that the temperatures are a certain way that it may impact it. We sell it for applications where we know the inrush current. So you can buy a breaker, and because we don't manage it, I mean, I could label a circuit breaker, a standard circuit breaker. It could be a high mag.
Mm-hmm.
And I could sell it into Home Depots anywhere just because, hey, we had a, we needed to fill an order, and you're not required to have a instantaneous on it anyway. So I label that as a standard thermal mag breaker, and I ship it to New York, where it may have only been out for Arizona or whatever. So it's still a 20 amp thermal mag 489 device. Mm-hmm. So the study looked at what are the typical instantaneous pickup values for circuit breakers. They came up with an equation to replicate the arcing, which was available fault current was the other one. And what UL 1699 uses is 500 amps, right? And so you have a minimum available fault current of 500 amps at the service, which was argued, right? This is why you saw public inputs, right?
This is good.
This is really good stuff because I learned so much. I learned so much watching this debate and being a part of it. We did research. The Wiring Device Manufacturers Consortium did research to find out what are the available fault currents at service panel boards for residential homes. And then the ACBMA, the American Circuit Breaker Manufacturers, went out and said, well, we're going to do studies too. Well, they all brought data to the table, and you're like, well, this is really great because you're getting a good cross-section of what fault currents are across the United States. And obviously, the wiring device guys brought stuff that said, hey, the fault currents are like 1,000 amps. And then the breaker guys said, hey, we had Donnie Cook was out measuring, and he brought data to the table, and other inspectors brought data to the table. And they said, we're seeing fault currents. My house here in Weirton, West Virginia was below 500 amps. It was 300 and some amps, So we were like, whoa, the fault currents are all over the board. 500 amps is a realistic number for a minimum because you want to make sure you're providing protection. And then you have sub panels. So it's not just the service. Like in this house here, I have a panel board in my basement, and I have a panel board upstairs in my bedroom. So the panel board, that conductor length is going to knock down the fault current at the secondary sub panel. And that all came up in the debates. We were looking at the reports and the studies, and we were like, okay, I had a Parks and Associates study, which was really good, but it didn't look at sub panels at all. And we're like, okay, well, the fault currents that you're finding is not quite on the mark. So then the other thing was they studied every manufacturer's instantaneous. So first off, we said, look, the fault current values aren't high. So you got to go with 500 amps. Then they said, okay, now let's take a look at the instantaneous pickup on circuit breakers. And they did a nice table of they had manufacturers A, B, C, and D. They had 15 amp and 20 amp breakers, and they found that circuit breaker positions in the electric panel board, they had, that's fault current. No, magnetic trip, greater than 500 amps on a 20 amp circuit breaker. greater than 500 amps. And they found out that not every manufacturer had the same instantaneous pickups. Why? Because it's not required by UL. So the instantaneous pickup values were all over the board. But we had to come up with an equation because they want, there was a desire to provide options, to your point, right? Because you've got somebody saying, I want to bring this to the market. So they used the equations in the second report. Well, actually, if you run the numbers, those links do not match the equations.
Oh,
No.
scandalous.
Well, here's the thing, and I didn't even realize it until I was on the copper clad aluminum task group, and because they want to use a 15 amp copper clad aluminum in residential homes because it's a new product, all this other good stuff. Well, they said, what about the AFCI protection? And so Chuck Mello did some research and he came up with a report, and his report said had 500 amps. But the instantaneous on the circuit breaker was like 120 amps or something like that. And I looked at that and I said, whoa, this is wrong because look, I have a report right here that says the magnetic pickups are greater than 500 amps or upwards of 500 amps. And he said, well, this is what makes the numbers work.
Right.
And he was right. I mean, I went back and so all of this research somehow, and I think it's just because of, you know how it goes, 2/3 arguing, debating back and forth. We ended up with 50 and 75 feet based upon equations from UL test reports. The effectiveness of circuit breakers in mitigating parallel arcing faults in home runs. This was January of 2012, revision 11. And then there was another one that came out. There's no date on this one, but this was in 2012 as well. I think it was August or October. So these equations, the magnetic pickup of a circuit breaker, the impedance of the conductor, the amount of available fault current, that was the recipe that was used to try to come up with two numbers of distance that could get 2/3 on the code panel.
Yep.
And have people walk away feeling like they did not lose a lot of protection.
Perfect.
Makes sense?
Good to know. Yeah, I mean, it makes sense to me. Absolutely. Very quickly, my first audio device is about to die, so I'm going to turn off my camera, switch over, dial in, and then come right back. Is that okay?
Yeah, you're fine. You're fine. So
Back in a jiffy.
All right, I'm just going to continue this one here. Okay, so that was now what happened was we had all of this research, all of these research papers, right? Had all of this data. Code Panel 2, Task Group 2 sat down, and you've got a lot of people arguing about providing options. And so we started with this one, saying, okay, we bring a pair of devices together. And the argument and the debate was, the breaker guys said, well, we don't want to reduce protection. We want to provide the equivalent protection. So we want to list these things together. And the receptacle people said, well, we don't want them to govern the decision on whether or not something can be brought to the table. So we ended up with a 3, which was a listed supplemental arc protection circuit breaker, because the circuit breaker guys said, look, we can list a breaker that will provide that protection of the home run circuit. I didn't know, Brian, that you could view UL standards for free. That is an interesting piece of the puzzle. Thanks for adding that. I'm gonna have to check that out, because I just had somebody else ask me to see a copy of the standard, and hey, I'll send them the link. So in this case here, we had a supplemental arc protection circuit breaker, which is a listed device. Sorry, I'm going to have to do something over here to get him back into this show, the program here. So we put this one in, and we set a listed supplemental arc protection breaker, but no standard exists to be able to make a listed supplemental arc protection circuit breaker. So we have no solution for this scenario. Bear with me here. Five. This one. Oh, he's back on. Oh, wow. Okay, perfect. I thought I had to turn this back on. Okay, good. So,
we good?
Yeah, we're good. So I was just explaining that there is no listed supplemental arc protection circuit breaker because there's no standard for it. This was simply this was a debate between these two groups of people. And it's not just the manufacturers, because there are some people that said, hey, we want options. We want to make this possible. And so they said, well, let's provide one option, which was this one, which was really the circuit breaker guys who said, we want to bring a supplemental arc protection breaker to the table. And maybe it's something that has just enough electronics in it that can just provide that protection for the home run circuit, and it helps make it a viable solution. And then 4 was put in because they said, well, they wanted these the OBC to be able to be put down of say a standard thermomagnetic breaker. It wasn't a electronic device, but based upon all of the data, that's almost impossible without having issues. So for list item 4, which says, over the years this has changed a little bit. I mean, I don't think it's changed really. It says the combination of the branch circuit overcurrent device and outlet branch circuit AFCI shall be identified as meeting the requirements for a system combination type AFCI and be listed as such. Now, what we did about 3 years ago was we made one. We made a listed device that's paired up with the OBC AFCI. They ship together. And they're listed to UL 1699 because they tried to make a standard for this. And it never passed ballot. There were multiple tries. But what was occurring was there was a faction of individuals that wanted to reduce the level of protection that was currently afforded. The code panel says we want to do that. The STP said we didn't want to do that, but because of the mix, we didn't get enough votes to actually create the standard. So then we said, why can't I just list it to UL 1699? And that's what we did. And we packaged them together. We worked with you all to make sure that we can do this correctly. And the tests are basically UL 1699 tests. And you can buy a listed device upstream, which is basically a UL 489 device. Now we have to put a little bit more extra sauce in the mixture to be able to provide that protection and pass the tests. But we have those two devices that are available, identical. And we provide the protection of the home run circuit and all of everything downstream. So in the last cycle, they were going to remove this. And we said, no, we just put a lot of money into making it. So, I mean, so, and then the people talk about removing list item 4 because they said, well, nothing exists. Well, Eaton spent money to make one. So you can buy one from us. So that is available. But item 3, this is not a product that's on the market. This one you can buy. Make sense? All right.
Sense to me.
Now, the other level of protection, again, worried about protection of the home run circuit. This used to be an exception. I think it was written as an exception. I'd have to look back at my book. But then we're saying, okay, now you can protect the home run circuit other ways. If you put it in MC, EMT, RMC, rigid metal conduit. I believe there is if you put it in concrete, maybe that's the next one.
I think it's the next one.
Yeah, that's the next one. So if you, and there was debate at panel 2 on what types of metal raceways are acceptable. And I wasn't on panel 2 at the time. I'm watching these debates whenever they were arguing these and things like that. So That's why I always say it's great to listen to the arguments and watch the debates, because you'll hear every angle to this from everybody on the panel. So if you provide that level of protection, and you know where they do this a lot? Chicago.
Is it really?
Yeah, Chicago is all in. I think it's rigid metal conduit. I think they use a conduit up there.
Wow.
Yeah, and that's part of the
Mhm.
building code. Yeah. So technically, you could use a standard thermomagnetic breaker with an OBC in those Chicago markets. That's the first place that my guys are. You should be up there talking about it with those guys.
Right.
And the other is having listed the MC cable is encased in not less than 2 inches of concrete for the portion of the branch circuit between the branch circuit overcurrent device and the first outlet. It shall be permitted to be installed in a listed outlet branch circuit AFCI at the first outlet to provide protection for the remaining portion of the circuit. So I can use a standard thermomagnetic breaker in options 5 and 6 as long as I'm providing protection of that home run circuit. And so that is A, right? So if you think about 210.12, A is for dwelling units only, 15 and 20 amp
Right.
circuits. And I have 6 options. Option number 1 is pretty much the de facto standard for most applications. All right. So now let's just talk real quickly about B, dormitory units. You know where that came from. Jim, not James. Oh my gosh. James from West Virginia. Man, oh day, I'm drawing a blank. Hopefully he's not watching. Anyway,
Jack Jameson?
no. Jim Williams. Wow. He brought up the fact that the statistics in dormitory units are very similar from an electrical fire perspective to the statistics that we saw in residential applications. And so we moved dormitory units into the National Electrical Code under 210.12b. It was Jim Williams who did that. And we have now dormitory unit bedrooms, living rooms, hallways, closets, bathrooms, and similar rooms shall be protected. Now, you notice the difference between B and A?
What's that?
We have bathrooms in B, which is interesting because panel 2, one of the rooms that we want to add in A is bathrooms. And we didn't pass it. And I'm scratching my head thinking, wait a second, guys. Whatever arguments that you have for not putting it over there, you've got it in B. Why the heck did you vote for it in B if you're not going to vote for it in dwelling unit? And I don't think it's about safety. But in any case.
Well, that's why I actually elect to live in a dormitory rather than living in a house, because I know I have more electrical safety in a dormitory than I do in a dwelling unit.
Well, so let me ask you a question. What is a dormitory?
Oh man, I've went rounds and rounds on this one, right?
Mm-hmm. Now, so
what's a dormitory unit?
That's
rather
right.
than a dormitory building.
Right. And you know why we have definitions. Okay. I used to think GFCIs drove definitions because the moment you have a requirement for a laundry area, all of a sudden, I don't know what a laundry area is. I have a GFCI requirement for a crawl space. I don't know what a crawl space is, right? That's not a crawl space. Well, wait a second. You got to get on your hands and knees to get in there, right? Yeah. Well, it's not a crawl space. Well, okay. So.
Yeah, well, okay. So this is I dislike this one strongly. Okay. Calling a cabinet a doorway is nonsense. That is insane. Okay. Unless you're a Keebler elf, that cabinet is not a doorway. Okay.
Keebler
if
elf.
You're the Indian in the closet. Like that
I love
is the
it.
only time that is a door. That's ridiculous.
I love it.
I'm glad it's cleared up now.
You know what? You may have just offended Keebler elves all over the place.
Well, I apologize. They make excellent cookies. I think Bakery Square in Pittsburgh used to be. Did they used to be Keebler?
I think right? So. Yeah. I think you're right.
There you go.
So because we put dormitory units in there and we needed a definition. It's a building or a space in a building in which a group of sleeping accommodations are provided for more than 16 persons who are not members of the same family in one room or a series of closely associated rooms under joint you need to get DNA testing. Okay?
I remember you saying.
you need to get DNA testing because how else are you going to determine if they are all of the same family? You know what I'm saying? I just love this definition. I don't know. And you know where we got
have people going on Maury to decide whether they're brother and sister, whether they need to have electrical protection. Is that what is going to be happening?
So you go in, you go, how many people are going to live here? 16. Oh, really? Are they, what's their last names? Well, we have 15 Dimitroviches and one Smith.
Right. To be honest, it's probably going to be the other way around. Like, for the most part, I mean, in this world, there's a lot more Smiths than there are Dimitroviches, from at least where I'm from.
Ryan says that 16 people in a family is really strange here. I love it. I love it. Anyway.
Ooh, boy.
Anyhow,
so much fun.
That's a dormitory unit. We had to define it. So I'm just going to grab the language here for a few of these other ones here. So here we go. So there's A. We already went through A. We talked about B. C. C is what happened?
Yes, the new exception for GFCI doorway exceptions is a no Keebler Elves.
Exception number one, right. Keebler Elves. Oh my God.
That's right.
That
informational notes.
Yeah, that's going to be right. It can't be. You can't have an exception for Keebler Elves. It's got to be an informational note on what a Keebler Elf is.
Informational note.
Oh my God, that is just that one's going to live on. You know that. You got that.
What an industry.
Legs. Gosh, and it's so. C is guest rooms, guest suites, and patient sleeping rooms. So, you know what? I can't remember. I don't believe we had fire statistics. I could be wrong. I can't remember the substantiation on this one, but we have guest rooms, guest suites, and patient sleeping rooms in nursing homes and limited care facilities. And we did. We said that these types of installations are very close. Pair character bowing down, saying thank you. Oh my God, you are hilarious, Ryan.
Oh boy.
Guest rooms, guest suites, and patient sleeping rooms in nursing homes. So these facilities are very similar to residential homes, right? So,
sure.
So that was the analogy that we did there, and we could not step on the toes of Article 517. 517 is healthcare. Yep, I'll buy him a beer next time I'm with him. Oh, NHZX boy. Talk to you later. We can finish this one a little bit later. 517 it basically gives me the permission. In 517 I'm picturing that Keebler, man. 517 where is it at? There it is. .10 applicability and what is not covered. Areas of nursing homes and limited care facilities, boom, wired in accordance with chapters 1 through 4, boom, of this code, where these areas are used exclusively as, boom, patient sleeping rooms. It's not covered by 517. So chapter 2, we got it done. And then D was, this is dealing, I don't like this one.
Oh, okay.
I hate 210.12D. I hated it when it went in. Here's why.
Take it up with the code making panel.
You know what? They're idiots. No, I'm talking about myself. But no, I wasn't. No, here's my issue with this. Okay. When you look at all of the arguments on AFCIs, okay, I'll even talk, even the home builders, right? They'll say the problem is not with new homes. The problem is with existing homes. Okay.
Right.
Now, you got 210.12d, circuit extensions or modifications. Where branch circuit wiring for any of the reasons specified in 210.12 A, B, or C is modified, replaced, or extended, the branch circuit shall be protected by one of the following. By any of the means in A1 through 6, so there's 6 options. A listed outlet branch circuit AFCI located at the first receptacle outlet. So we're saying, okay, I'm not going to worry about the home run circuit for an existing home. We just want it in existing homes. Okay? But read the exception. AFCI protection shall not be required where the extension of the existing branch circuit conductors is not more than 6 foot and does not include any additional outlets or devices other than splicing devices. This measurement shall not include the conductors inside an enclosure. So I change out my panel board, my service entrance. I don't have to put AFCIs. I change receptacles out. We can argue because we can go back to 406. What is it, 406? 406 receptacles?
406.4D.
406.4D, right. 406.4D replacements 4D4 is the AFCI one. If a receptacle outlet located in any area specified in A, B, C, or D, replacement of the receptacle shall be... Now read this. What does this say? A receptacle outlet located in any areas specified, a replacement receptacle at this outlet shall be one of the following. So if you replace the outlet, so in an existing home, I got to replace the entire outlet, but then I've got this. I'm modifying. The reason this is in there, and I remember this discussion and debate at panel 2. The reason they put this in was because they wanted AFCI requirements in existing homes, but they said what they did not want to do is deter somebody from a service upgrade. They said what'll happen is instead of upgrading the service, I remember this exact conversation. I can't remember who it was that said it, but he said what they will do instead of upgrading the service, they will install a little panel and keep the service. The 1923 stuff that should have been removed, they're going to leave it and just add a separate little box or
like a sub panel?
Yeah, like a little sub panel, or they'll just tap off of an existing circuit or whatever. They did not want to deter replacing the service. They're having people think that you have to now bring every branch circuit has to be AFCI protected because, I mean, I have knob and tube. Remember when this went in, I'd have to look if the combination AFCI was required. Let me look at the. I'd have to look at the 05 code too. I got the 11 here.
He's breaking out the scrolls, the tablets.
The scrolls. 210.12. What is it? D, right? Okay. In the 11 cycle, it wasn't. Oh wait, in the 11 cycle, it was not there. No, we did. We had it. It looks like it was new in the 11 cycle. And yeah, it did have the combination type. So I want to sneeze. I don't want to sneeze. It looks like it was new in the 11 code. So they put it in 2008 for combination, right? So it was the cycle before this. And so in any case, they were arguing about putting it in for existing homes. And when they threw that exception in, I just think they gutted it. I mean, if the only time this is going to impact you is if you're adding a new circuit in a residential home, right? You're doing an addition to your house. that's already covered. Because if you're going to do an addition to the house, you're going to pull a permit, and what are they going to enforce for that addition? The latest version of the code, which will inquire
The
AFCI
latest
protection.
edition of the
Well,
adopted code
yeah,
in that state.
you're right. I think Pennsylvania is still on the 11th. So that was my and my argument was it didn't make sense, because if you do the additions, then you're going to have AFCI. The challenge is how do we get AFCI protection into existing homes? And then if it's an existing, you change a receptacle out, are you pulling a permit? No. Right? You're relying on the conscientious electrician who's going to say, oh, I have to put an AFCI receptacle here. The chances of that happening, I just get frustrated with 210.12d. I really do. I know the intent of it. I know why they put the exception in, was because they did not want, and I think it was IAEI, and they made a valid point. The concern was that they're probably not going to update the service to the latest technologies, because if they have to put AFCI protection, that means they're going to have to fix the sins of the father throughout the entire house.
Okay, so I have a question. So if you're going through the pain of putting in an addition to your house, is updating the electrical that much of a
but wait a second.
extra cost?
It depends. When you're talking about the existing, like for example, this house here that I'm in, right?
Yeah, right.
When I had my water damage,
2,500 square feet, 25,000 square feet.
Yeah. When I had my water damage go through this house, they changed the panel board out, right? I bought all of the breakers. I bought all GFCI circuit breakers. Okay. Every one of them are GFCI, because I couldn't get the AFCI GFCIs. I just said, I'm at least going to put GFCIs, and I've changed them out since, but they were all GFCIs. My electrician called me. He goes, Mr. Dimitrovich, I see the parts you bought, because I bought the panel board, I bought the surge, all this good stuff, right? And I said, he goes, you bought the wrong circuit breakers. He goes, you spent a lot of money on circuit breakers you didn't need. And I said, well, no, they're all GFCIs. He says, yeah. He says, well, you're not required to have GFCIs. He says, you've got receptacles. I said, no, I want a GFCI protect all my circuits. He goes, well, they're not going to hold. And I said, well, if they don't hold, that means current is going somewhere where it shouldn't, and you're going to fix it, and State Farm's going to help us pay for it. Don't pay your time, right? Because they weren't replacing all the can lights. They weren't replacing any of the wire. If there's a problem in there, I want to know about it. Well, they shared a lot of neutrals in this house that they should not have shared. They had can lights. They were very poor in getting the conductors into the can lights. I had a lot of nicked conductors. After the fact, I found a receptacle. One of my receptacles on my outside circuit is no longer there. I had to remove it because, and I've got multiple receptacles always around this house. And the one's gone because they pulled the conductor from inside the house to outside the house, and they damaged the conductor, and it was tripping my GFCI because there was a box, and it was going line to ground. So finding those issues in a house that was built in the 20s or earlier, a knob and tube, they stole neutrals everywhere. So it is a realistic challenge. I cannot argue that trying to update the wiring inside of a residential home to the latest, to include an unforgiving technology can, yes, be a challenge. But those are the homes that are contributing to the fire statistics as well as the new homes that get old. So the logic that they used, and I heard that debate, I think that we probably could have had better language there, because the only concern was service upgrades. And that's all you had to do is say, look, if you're doing a service upgrade, you don't need to update AFCI protection for the entire home. But if you are modifying, to your point, I'm modifying a branch circuit, I'm pulling things out, I'm changing things around. Am I going to, all I have to do is say, well, am I moving not more than 6 foot of conductor? I don't know. I just have heartburn with this one. It irritated me. It irritated
Well,
me.
Tom, we look forward to your
Public input.
public opinion
Yes, I know. So
for the 2026.
I know. Yeah, I know. So we got through 210.12 because that was the last one, I believe. D. So we went
Right.
through. This is the first time I've ever really gone through 210.12 A, B, C, and D. And we talked about Tamaki's question with the kitchens. We not talked about the compatibility. Somebody else asked one other question. Just want to make sure that I get his question asked, or no, I don't want to get his question asked. I want to get his question answered, and then we can shut this stream down because we've gone for 2 hours, which we were only
That's
supposed to
true.
go for an hour. But you know what? I just had to blow through it. He said, smoke alarms, if not monitored by a fire panel, smoke detectors. Oh, there is some exceptions in 210.12. I can hear Jake chewing on a bone on the floor up there. AFCIs are not required on, I'm looking for it.
I think it's below 4. And for number 6, exception AFCI protection shall not be required for an individual brain circuit supplying a fire alarm system installed in accordance to 706 41B or 760 121B. The brain circuit shall be installed in a metal raceway, metal auxiliary gutter, steel armor cable type MC or type AC, meeting the applicable requirements of Article 250-118 with metal boxes, conduit bodies, and enclosures.
And this just came up on, it just came up on the correlating committee, this section. And the reason is because they're saying that 760 in the code, 141B and 121B covers, I'll just 121B. I just don't want to, I want to make sure that I'm looking again, I'm in the 2020 code. Branch circuits, this is talking about the fire alarm circuit. And it says in here, the fire alarm branch circuit disconnecting means shall be permitted to be secured, blah, blah, blah. It doesn't say, it does say in here that it shall not be supplied. The branch circuit shall not be supplied through ground fault circuit interrupters or arc fault circuit interrupters. Okay, so the correlating committee just had this debate. And you're welcome, Tamaki. Thanks for dialing in. So the correlating committee just had this debate saying that, look, 210.12 should not be saying that a fire alarm system installed in accordance with 760.41B or 121B, because and you can't say that you're not permitted to put it on the AFCI because it's already in 760. Okay, so 760 trumps the AFCI requirements already. So 760 says you're not allowed to put AFCI on a fire alarm circuit. So if I want to follow the style manual for the National Electrical Code, I can't repeat it in panel 2 in 210.12. But what this exception does is it says that would not be covered in 760, that you need to protect, if that fire alarm circuit is in a residential dwelling unit that would require AFCI, then you need to protect that home run circuit with a type MC or type AC cable meeting the applicable requirements of 250-118 with metal boxes, conduit bodies, and enclosures. So what 210.12 does is it recognizes what 760 tells you. So it doesn't have to regurgitate that. If it's a fire alarm circuit,
Right.
you need to be looking at 760 anyway and follow all those rules. So you would know that in 760, you are not permitted to have it on an AFCI circuit. But what 210.12 tells you is you need to protect that home run circuit that feeds that fire alarm circuit in other methods which would be the MC cable, etc., like you see in options 5, right? So we're going to have to reword this in the 2023 cycle, but to get that right, to get the requirement out of there, and just basically say, look, if it's a circuit that's a 760, if it's an Article 760 fire alarm system in a residential home on a 15 or a 20 amp circuit, you need to protect it in a metal raceway and give the methods. We don't have to tell you that you're not allowed to have AFCI protection on it because it's already in 760. So, and that's the only difference there. And I think that covers the question that came in from Robert. It covers all of the requirements. We talked a little bit about the technology. We talked a lot about that. We dispelled the myths of parallel series, right? And we answered Tamaki's question on how to do this in kitchens. So I don't know about you, but I think it was a successful 2 hours. And look at this, my buddy Nahazix Boy stuck in there till 1843. I love it.
Pretty good. Very good.
All
and
right.
we appreciate anybody who stuck away all the way to the end.
That's exactly right. And we were going to do an hour, but you know what? While we're here, might as well just get it done. So next Tuesday, it'll be an hour.
Oh, what's for next Tuesday?
Next Tuesday, let's take a look at the schedule. The schedule says, you know how I find out what the schedule is? You know how I know?
There you go. Where is the schedule?
Where is the schedule? Well, this is where the schedule is. I go to thomasdomitrovich.com and I go to calendar of events after I subscribe. Cool. Thanks, brother. You know, you were the instigator. Wow, that's May 11th? Is that May 11th? Hold on.
Yeah, that sounds right.
Wow, I have to get, all right, yeah, it is. I got to call my buddy. So we're going to be talking personal protective equipment, and we're going to have Scott Margolin, I hope I get that right, on board. And you know what I'm going to do, David?
What's up?
Scott is going to be my first Buck 41.
Whoa.
Yes.
Whoa.
Should I tell people about the Buck 41 Club?
Hold it.
All right. I will do the introduction for the Buck 41 Club on the 11th in the beginning as I introduce Scott.
How about that?
And that'll give him an incentive to remember we got to do a program on Tuesday that he committed to. Whoops.
It's pretty incredible because, you know, my understanding of the Buck 41 Club is that means he's an avid hunter and he has gotten one buck at minimum in 41 days in one hunting season. That's incredible.
We don't kill animals on this program either. So.
No, that's for our other program.
Yeah, that's for the other program. That's for our hunting show. No, it doesn't have anything to do with bucks and does. But we are going to share the elite Buck 41 Club
and you'll find out what the Buck 41 Club is on Tuesday.
Yes, on the 11th.
That's how they do it in the business. You got to give the.
Oh, is that right? Is that what it is? Is you call it the business?
Yeah, a little teaser. That's right, the biz.
All right. The Buck 41
He's
Club.
had enough with me. I saw that face change.
Yes.
He's had 2 hours with David Smith over here. He's done. I'm never coming back. I'm never going to be allowed to come back. Thank you very much, everybody. This is going to be my last show.
Yes, it is. Oh my gosh. Well, excellent. So Felix Sandoval, thanks for the questions. Ryan Jackson, research number 1. Thanks for joining us. Boy, wish you were here still. Kevin Breen, thanks. David Engelhart was in the house a little late, but he's worth the wait. I'm just looking back at some of the names. We had some good, Kevin Breen, we had some good dialogue. So thanks everybody for hanging in there. And thank you, Ryan. And no, the Keebler comment makes it. Yes, it does. Keeblers for everybody. All right, everybody. Well, Well, we are going to sign off, and I'm going to let David get back and get to work. I got to go make a cart for my wife. So. All right.
Good stuff. Well,
Yes.
again, thank you everybody for coming on. If you go on LinkedIn or YouTube, click that hashtag Eaton Tech Talk, and you'll find all the rest of them. Like and subscribe.
Yes.
All that kind of stuff. And yeah, please drop us a line if you have any questions or anything like that, particularly whenever it comes to code adoption.
Yep.
Right.
Yep. And go ahead.
Yeah, go ahead.
No, see, and what I'm going to do for the Buck 41 Club, I'm working on a form so that if once they learn about the Buck 41 Club, they can do a submission to see if they can get somebody into the Buck 41 Club.
I believe that is considered a nomination.
Is that what they call it? A nomination for the Buck 41?
I believe that's what they call it in the business.
See,
I'll tell you about it.
What would I do without you, babe? Don't know where I'd be.
I know exactly where I'd be. Not here.
All right, everybody. With that, have a great weekend. Good night, David. Good night, Kevin, Tamaki, Japan, Felix Sandoval, everybody. Thank you for what you do for the electrical industry. Thanks for what you do for electrical safety. Remember, stay safe, and please stay healthy.
Right.
All right, David, I'm just going to do my little ending screen. And we are still on audio and saying goodbye to everybody.
On audio.
Yeah.
Yep.